All right, welcome back. Um, what we were talking about last time is we were talking about running a general population simulation. We created a run simulation function that is not dependent on our model. And now our goal will be to figure out, for the different models we've discussed, what do we need in our system object, and what do we need in our growth function to be. All right, so let's talk about the system object. Oh, I have changed my color to a nice magenta. All right, so system object. All right, so in our system object, which was this yellow thing from above, what do we need to have in it? So every system object has to have T naught in it, and T end in it, and P naught in it. So in our different models, so we had our constant growth model, we had our proportional growth model, and then we had our quadratic growth model. All right, in our constant growth model, so we have our bag of variables here. In our bag of variables, we must have T naught in it, we must have T end in it, and we must have P naught in it. And so we're saying those have to be in all three of these bags. So T naught, T end, and P naught, T naught, T end, and P naught. But then we also need the parameters that the system needs to know in order to do the growth that we prescribe. So also include the parameters we need to run the growth function. Right? The growth function is how we get from time t to time t plus 1. So in the constant growth function, we need the annual growth. We need that constant of how much the population increases from time t to time t plus 1. In the proportional growth, we need the birth rate, and we need the death rate. And in the quadratic growth, we need the alpha and the beta. Okay, so those are the parameters that we need to be able to run our simulation. And next is to find what does the growth function look like. So here are the parameters that we need to bring in. And now let's talk about the the growth function. So what we're going to do is define the growth function for a constant growth, right? And that's supposed to take in, let's go look at our structure. It has to take in the current time, it has to take in the current population, and it has to take in the system object. So we have T, pop, and system. We pass that information in, and what's the growth? What is the rule that gets us from time t to time t plus 1? Well, we need to return, right? What's the growth? The growth in the constant growth function is just the value of the annual growth. So we're going to return annual growth. So no matter what time it is and no matter what population it is, oops, we still need to return the annual growth, which isn't something that this function knows. It's located in the system object, system.annualGrowth. So let's take a quick look at how this works in the run simulation. Right, in the run simulation, we get to this part where we have to calculate the growth. The growth becomes that annual growth, and then results of t plus 1 is equal to results of t plus that annual growth. Great, that's what we wanted it to be. All right, that's the growth function for the constant growth. I forgot my colon. I forgot this colon here. All right, next, let's talk about the growth function for the proportional growth. Well, in that case, we still need to take in the time, the population, and the system. But this time we don't return the annual growth. We have to return the growth, how much have we grown based on the birth rate and the death rate. Right? So what we need to return is system.birthrate minus system.deathrate times the population. And this is the rule that takes the current population, multiplies by the birth rate to say how many new people are added to the system, multiply by the death rate to see how many people are removed from the system, and subtract the two of them. So that's what the proportional growth function would be. Last, we can talk about the growth function for the quadratic. Takes in t, population, and system. What does that look like? Well, it needs to output what the change in the quadratic growth value is, which we said was going to be system.alpha times pop plus system.beta times pop. So pop squared. We could write times pop, or we can use pop star star 2, which means pop squared. So in terms of what we're seeing here, when we're dealing with the different growth functions in the different regimes, we have a different bag of variables, different system objects, and we have different growth functions. Right, we could say these are our yellow bags of variables, and then we can say, I think the green was the right color. This green is this growth function. All right, so now let's go over to Python, put it in the computer, and see it in action. All right, so this is a modification of the file that Professor Downey has used and created. What I've done is I've integrated all three of the growth models into one file here. All right, so we need to install Pint, download the information, and then we can have a table. This function plot estimates brings in the plot of the census function, the plot of the UN function, decorates it. And we're finally getting to this red part of our simulation in which we define the run simulation function, right? So we create a time series. We create the results. We initialize it to what is happening at the first time and the first population. and then we run the growth function in a loop as many times as we need to, and we return the results. So our constant growth function, I think I need to evaluate this. Our constant growth function takes just returns system.annual growth. So once we create our bag of variables, our system object that has our initial t naught, the end value of t, the initial population, the end population, and that lets us calculate annual growth, we create this system object where we say, all right, we need t naught, and we're going to define it to be what this t naught was defined outside. We need a variable named t end, and we're going to define it to be what it was defined outside. We have p naught, and that's going to be defined to be what it was defined outside. And annual growth is going to be defined to be what it is outside. So this is a little bit confusing for the first few times you see it. You see this t naught equals t naught. What that means is that we're creating a variable in this system object called t naught, and we're defining it to be what the value of t naught was outside of the function, outside of this system object. So it's really weird. This t naught means something different than this t naught. This is a variable name, and this is the variable that was defined outside. So when we run this, and we run this, and we maybe show what the system says, the system has an annual growth, p naught, p dot, t naught, t end. Give me 1 second. Okay, in that short pause there, I figured out what was wrong here, and it has to do with some of the changes that were made in the ModSim package between version 3 and version 4 of the book. The thing I was unhappy with is that when I ran this code that just said system, I was really hoping that it would show me a table of information. But in the new version of the ModSim package, that's not what happens here. It doesn't just show us a picture. You actually have to write show of system, and then what it does is it will put that into a nice tabular form like we had before. Alright, so there's a couple of things that we need to relearn in terms of how to see this information, and this is one of them. You have to use show of your object to be able to see what it looks like. And let me get to another one in a short moment. So now we created the system object, and we created our growth function up here, and now we can put those both into the simulation. Let's see what happens if we get this. Can we do show of results? Do I need to do show of results? Show of results puts this into a nice picture. And the last thing is we want to visualize it. So let me show you the other thing that's changed from the previous version of ModSim that was from Chapter 3 to this version of ModSim, which is Chapter 4. Before we used to write plot of results, right? We used to write this code, plot of results. And so now, if we tried that, it says plot is not defined. Okay, it says plot is not defined because before plot was a function that was defined in the ModSim package. And now it's no longer defined there because of probably a good reason. The good reason is if you're using Python outside of this class, there's no plot function except if you import ModSim. So Professor Downey has told me earlier he was planning to make this more standard in terms of how you use Python out there in the real world. And so the way you do that is you take this object, this series object, results, right? This results object, and you use a dot operator. This results dot plot takes the results dot plot uses matplot library and generates this picture. So if you want to make this picture prettier, you can do that. So you can change it and put in some colors and some labels into your plot, and then that starts to give us some useful information. And then this decorate function that is part of ModSim puts things on axes and puts things on as titles. So things have changed a little bit, and so this is something that you'll have to get used to. All right, so we've created the results. So this plotted the results object, and then this plots the UN data and the census data, and then this puts it all together. The decorate puts in the labels on the title, and this function, this save fig function, allows us to access this as a PDF. So if you go over to your folder, you can see the PDF file that was generated when you save the figure. So instead of like dragging this into a new tab and looking at what the picture looks like, you can actually have a PDF file that you can import into your documents as well. All right, so we got a little bit sidetracked there because of these new things that we had to learn. But now we learned all those things, and we can just apply this to the proportional growth model. So we have the growth function. Here's a slightly different. Like if you see this, you can actually calculate the number of births and the number of deaths, and you subtract the number of deaths from the number of births, and that's how much it's grown. So you could either put this in one line or you can put it into 3 lines. Maybe it's a little bit more readable. So we create our system object. We add in what the death rate is and the birth rate is into the system. We run the results. We run the simulation. And when we do that, we get this gray line as a proportional growth model. And as you remember, that gives us an exponential function for the population, which doesn't really fit the data so well. It's also possible to combine the birth rate and the death rate together. So if we talked about a growth rate, which would be the birth rate minus the death rate, so the net change rate in population, that we call this alpha, then we can run the simulation with this new variable. We had to put that as a system parameter in our bag of variables. And then we have, when we run the simulation, we run it with this new growth function. And because we really haven't changed anything, we get the exact same picture. We've just maybe simplified this by having one variable instead of 2. Last here is the quadratic growth model. And in the quadratic growth model, then we defined, remember, system.alpha times population plus system.beta times the square of the population. And then we need our bag of variables. We add in our extra bags of variables, where what the alpha is and what the beta is. And then when we run the simulation, we can get a new picture. All right, let's stop there, and we'll see you next time.